Imagine a journey that starts in a place completely microscopic, smaller than you can possibly imagine, and ends out in the vast, sometimes foggy forests of human learning. Today, we're going to take a slow, really wondrous look at how the biology of our brains directly shapes the way we explore, understand, and map out the world through the things we learn. So take a deep breath, step off that predefined tour bus, and let's go on a quest.
For the longest time, we sort of thought of the human brain as this fixed, hardwired machine, like a computer you couldn't upgrade. But that couldn't be further from the truth. Your brain is actually a living, breathing universe of glowing fibers. It's incredibly dynamic, constantly changing, growing, and developing over your entire lifetime. And just take a second to wrap your head around the sheer scale of it. 86 billion. That's the number of individual nerve cells, or neurons, making up your mind. To put that into perspective, it is quite literally like looking up on a clear night and trying to count a sky full of countless glowing stars. And every single one of those neurons is just sitting there, waiting to connect, waiting to form a brand new thought, a memory, or a fresh understanding. So, how do those 86 billion individual stars actually connect? Well, they communicate across this tiny microscopic gap called a synapse. And this right here, this is the absolute foundation of all learning. Neurons talk to one another across this gap using these beautiful electrical sparks and chemical signals. So every time you learn something new, these neurons light up and fire together, physically building the actual pathways of human thought. But here is where it gets really interesting. Our brains also have this unbelievable natural superpower, the power to ignore. It's a biological process called neural pruning. Basically, if a neural pathway isn't being used, the brain just naturally lets it go. The connection stops. It's exactly like walking through a dark forest. If a trail is left untraveled for too long, it just eventually fades away into the underbrush, completely forgotten. But don't worry, because our brains have another absolutely beautiful ability called neuroplasticity. This is our power to grow new pathways at literally any age. When we focus on something, when we struggle with a concept, and when we really engage, our brains are constantly laying down fresh, glowing trails right through the unknown. The physical structure of your mind actually bends and shapes itself to the journey you choose to take. Okay, so let's zoom out from the microscopic level for a second and look at our macro journey. If learning is physically building these glowing pathways, and forgetting is the natural pruning of the ones we aren't using, well, how do we build an educational journey, a map really, that ensures the pathways we actually care about survive the fog? How do we step into the wild forest of learning without getting completely lost? To build that kind of map, we first have to realize that our 86 billion neurons don't all prefer to travel the same way. In fact, we have two fundamental ways our brains like to learn. First, there's the spiderweb brain. This type of brain desperately needs a big why. It needs a giant, sticky web to hang all the disconnected facts onto so they actually make sense. But deliberately contrast that with the inchworm brain. This is a brain that likes to take things step by step. It needs small, manageable crumbs of what? Little stepping stones that will eventually connect for one big aha moment. And what's absolutely fascinating, and honestly a bit surprising, is that you aren't just one or the other. A traveler can physically shift back and forth between these two brains right in the middle of a really complex challenge. And you can actually feel it happening. When a step-by-step inchworm brain suddenly needs the grand spiderweb why, or a spiderweb brain gets overwhelmed and desperately needs inchworm stepping stones, there's a physical reaction. You might literally feel your body temperature rise, your muscles tighten up, and you might even let out an involuntary sigh of frustration or realization. Because we naturally shift back and forth like this, our map requires two distinct things. First, we need the big why. We call these essential questions. I want you to think of essential questions as our guiding stars in that dark, foggy forest. They provide the overarching meaning, that grand web that keeps a traveler moving forward and keeps them from throwing in the towel when the path gets really tough. But for an essential question to act as a true guiding star, it has to be approachable. Take a look at this one. How can my knowledge of math help me make better decisions? Notice the incredibly empowering use of the words my and me in there. This puts the traveler in complete control of their own compass, rather than just blindly following a teacher's map. It's a guiding star that a kindergartner or high school senior can both successfully use to light their way. But here's the catch. You can't just stare up at the stars forever. You have to watch where you're walking. And that brings us to our learning targets. These represent the what. They are the inchworm's breadcrumbs. If the essential question is our star, the learning targets are the steady, sequential stepping stones right beneath our feet. Things like, what is a percent? What is a decimal? How do I actually convert them to make a choice? These are doable, granular targets that make the whole journey accessible. When you pull it all together, look at how beautifully this architecture stacks up. Every great learning quest aligns perfectly like this. We have the why up at the top, our essential questions acting as our guiding stars. We have the what right in the middle, our learning targets acting as our stepping stones. And finally, the how at the bottom, the daily lessons and activities that move us safely and steadily from one stone to the next. But let's be real, here is where we often run into serious trouble. Our educational pathways frequently just get way too crowded. When a learning path tries to do everything all at once, it forces the traveler to rush. It damages the mental well-being of both the teacher and the learner, and worst of all, it completely breaks that natural spark of curiosity. Think about it, you really can't enjoy the forest if you're sprinting through the fog in a total panic. So how do we relieve that intense pressure? We use a tool called a year-long context. Think of it as a really reliable map for survival. Instead of forcing someone to carry a heavy, overflowing backpack of facts all at once, a year-long context places our essential stepping stones carefully out along a timeline. It tells us exactly what is absolutely critical to learn and where we actually have the freedom to just wander and explore. This timeline naturally creates a really nice rhythm for the journey. For example, we master our first set of stepping stones in September. We encounter the next set in November. But look at May. We return to the stars and repeat our bundles. Let's connect this right back to the biology we talked about. Returning to these ideas months later is exactly how we keep those neural pathways firing and glowing. By circling back to the concepts, we actively stop that natural neural pruning from sweeping our hard-earned trails away. When we align our biology with our learning like this, it's a total game changer. It empowers the explorer to finally step off that predetermined tour bus. But to brave the forest path safely, an explorer always needs three things: a genuinely interesting emotional hook that makes the problem worth the effort, a steady rhythm of small, manageable goals so they don't get overwhelmed, and a community of support. Learning thrives on connection, turning an individual struggle into a collective victory. Once the paved road ends and that tour bus is far behind, the explorer really must rely on self-navigation. This is their internal compass. It's an internal process that ensures that even when things get highly complex and the fog starts rolling in, the student is never truly lost in the dark. Mastering that internal compass really comes down to what we playfully call the 4 selfies of navigation. It's simply about pausing, taking a breath, and gently asking yourself, what have I done so far? How am I doing right now? Where am I going next? And most importantly, can I actually do this? Because if a learner believes a task is doable, they motivate themselves to take action rather than retreating. These 4 simple questions can turn any intimidating challenge into a highly manageable victory. Ultimately, you might be wondering, why does all this structure matter so much? It's because apathy is literally the tool of forgetting. Remember our glowing synapses? Genuine emotion, whether it is the joyful thrill of discovery or even the intense frustration of a difficult struggle, sparks those electrical signals and locks in those glowing brain pathways. Apathy, on the other hand, just causes those unlit trails to fade quietly away into the fog. We have to design our journeys to declare a full-on war on apathy. We've moved all the way from 86 billion microscopic neurons to the vast open map of curriculum design. And the science shows us that our brains are quite literally built to adapt, to seek out stars, and to follow stepping stones. So I'll leave you with this final thought. When you step off the tour bus and look up at the vast night sky of your own potential, where is your internal compass guiding you next? Thanks for taking this journey with me today. Keep exploring.